They reached for the stars, but a routine test inside their capsule became a fiery tomb. This inferno... Welcome to the channel. Today we explore one of history's most dramatic engineering failures. On January 27, 1967, three American astronauts, Gus Grissom, Ed White, and Roger Chaffee, prepared for a routine plugs-out test on the launch pad at Cape Kennedy. They were inside the Apollo 1 command module, a vehicle designed to take humanity to the moon. What began as a simulated countdown for a mission of exploration tragically ended in an inferno, a devastating fire that claimed their lives and brought the nascent Apollo program to a grinding halt. The fateful day began with what was intended to be a benign plugs-out test, a crucial rehearsal for the first crewed flight of the Apollo program, designated AS-204. Astronauts Grissom, White, and Chaffee were sealed inside the Apollo 1 command module atop Launch Complex 34, simulating the full countdown sequence without fuel in the rocket. The test was designed to ensure all systems functioned independently of external power, mirroring actual flight conditions. Throughout the day, the test was plagued by minor malfunctions and communication issues, causing delays and frustration for the crew and ground control. As the simulated countdown neared its final minutes, at precisely 6:31 p.m. EST, a sudden surge in oxygen flow was detected. Within seconds, a chilling cry of "fire" was broadcast from the capsule, followed by frantic calls and the sound of struggling. The fire, fueled by a pure oxygen environment, spread with terrifying speed. Less than 15 seconds after the first alarm, the command module's internal pressure soared, and all telemetry and voice communications ceased. Ground crews, immediately realizing the gravity of the situation, struggled desperately to open the complex inward-opening hatch, but the intense heat and internal pressure made their efforts agonizingly slow. By the time they succeeded minutes later, the tragedy was complete. The Apollo 1 mission utilized the Block 1 design of the command module, an early iteration of the spacecraft intended for the lunar missions. This module was a sophisticated piece of engineering, but it contained several critical design choices that would later prove catastrophic. One fundamental aspect was the cabin atmosphere during ground tests and early flight phases. A pure oxygen environment maintained at 16.7 pounds per square inch, SI, significantly higher than the Earth's standard atmospheric pressure of 14.7 psi. This high-pressure, pure oxygen atmosphere was chosen for its simplicity and to reduce structural weight, but it created an extremely volatile environment where even normally slow-burning materials would ignite and spread flames with explosive rapidity. Compounding this risk was the widespread use of flammable materials throughout the cabin interior. And items like nylon netting, Velcro fasteners, and various plastic components, though common at the time, were highly combustible in such an oxygen-rich atmosphere. Adding to these engineering vulnerabilities was the module's three-part, inward-opening hatch. While designed to provide a secure seal during spaceflight, its complex mechanism required several minutes to open from the inside, even under normal conditions. In an emergency, with internal pressure rapidly building from a fire, the hatch became effectively impossible to open, trapping the crew inside their burning capsule. Even before the fatal test, the Apollo 1 crew had voiced significant concerns about the command module and the overall state of the program. Astronaut Gus Grissom, a veteran of Mercury and Gemini missions, had famously expressed his unease, calling the Block 1 capsule shaky, and even hanging a lemon on a simulator to symbolize his dissatisfaction with its readiness. These were not isolated complaints, but rather reflections of broader issues within the nascent Apollo program. A particularly alarming incident occurred during a previous test just weeks before the fire. The crew reported a persistent, pungent, bad smell in the cabin, likened to sour milk, which ultimately led to the cancellation of that test. While the source of the odor was never definitively identified or fully rectified, It highlighted a laxness in quality control and a potential disregard for crew concerns regarding the cabin environment. Beyond these direct warnings, there was a general awareness of the fire hazard posed by the pure oxygen atmosphere and the extensive use of flammable materials. Internal NASA reports and safety reviews had previously noted the risks associated with such an environment and the need for better housekeeping regarding combustible items. However, the urgency of meeting ambitious lunar deadlines often overshadowed a thorough address of these known vulnerabilities, creating a perilous confluence of design flaws and operational pressures. The subsequent investigation meticulously pieced together the sequence of events that led to the inferno. The most probable ignition source was identified as an electrical arc, likely originating from a frayed wire located near Gus Grissom's couch, possibly within the wiring bundle for the environmental control system. This arc, though small, was sufficient to ignite the highly volatile environment of the pure oxygen cabin. Once ignited, the fire spread with horrific speed. The 16.7 psi pure oxygen atmosphere acted as a powerful accelerant, causing flames to engulf the cabin in mere seconds. The extensive use of flammable materials, such as nylon nets, Velcro strips, and various plastic components, provided abundant fuel, transforming the command module into a death trap. These materials, which would smolder slowly in ambient air, burst into intense flames in the oxygen-rich environment. As the fire raged, the internal temperature skyrocketed, and the pressure inside the sealed capsule rapidly built up. The inward opening hatch, already difficult to operate, became impossible to open against this immense internal pressure, which reportedly reached as high as 29 psi. Trapped inside the rapidly consuming inferno, the astronauts succumbed to asphyxiation and severe burns, their escape rendered impossible by a combination of design flaws and a highly combustible environment. The Apollo 1 fire was an unprecedented disaster for NASA and the nascent American space program. All three astronauts, Lieutenant Colonel Virgil Gus Grissom, Lieutenant Colonel Edward H. White II, and Lieutenant Seander Roger B. Chaffee, perished inside the command module. Their deaths marked the first fatalities in the history of U.S. spaceflight during a mission or test, sending shockwaves through the nation and the world. The command module itself was utterly destroyed internally, a testament to the ferocity of the blaze. The immediate aftermath was one of profound shock, grief, and intense scrutiny. The Apollo program, which had been racing towards the moon, came to an abrupt and complete halt. Public confidence in NASA was severely shaken, and there was a palpable sense of national mourning for the lost crew. Recognizing the gravity of the situation, NASA Administrator James Webb immediately established an independent accident review board to thoroughly investigate the cause of the tragedy, vowing to uncover every detail and implement every necessary change to prevent future occurrences. The official investigation, conducted by the Apollo 204 Review Board, was exhaustive and unflinching. Its findings were stark and critical, revealing a complex interplay of design flaws, procedural shortcomings, and oversight failures. The board confirmed that the source of ignition was most likely an electrical arc, probably from faulty wiring, which found ample fuel in the cabin's highly flammable materials. The pure oxygen atmosphere, maintained at an elevated pressure, was identified as the primary accelerant, turning a spark into an uncontrollable inferno in seconds. Crucially, the investigation highlighted the fatal flaw of the inward opening hatch, which became an insurmountable barrier to escape once internal pressure rapidly increased. Beyond the immediate causes, the board's findings pointed to broader deficiencies in the design, manufacturing, quality control, and testing procedures for the Block 1 command module. The report concluded that the Apollo program was in a hazardous condition and that there was a failure to adequately assess and mitigate the fire risks associated with the cabin environment and materials. NASA, under Administrator Webb, accepted full responsibility for the accident, acknowledging the systemic issues that contributed to the tragedy. The transparency and thoroughness of the investigation, though painful, laid the groundwork for a complete reevaluation of safety protocols and engineering practices across the entire agency. The Apollo 1 fire became a crucible for NASA, forcing a fundamental reevaluation and overhaul of the entire Apollo program. The most immediate and significant change was a complete redesign of the command module, resulting in the Block 2 version. This new design incorporated an outward-opening, quick-release hatch that could be opened in seconds, even under emergency conditions, addressing one of the most critical failures of the original module. Furthermore, the cabin atmosphere protocols were drastically revised. During ground tests, the pure oxygen environment was replaced with a mixed gas atmosphere, 60% nitrogen, 40% oxygen, at a reduced pressure of 5 psi, significantly mitigating the fire hazard. All flammable materials were systematically removed from the cabin interior and replaced with non-combustible alternatives such as fire-resistant fabrics and wiring insulation. Every component was rigorously tested for flammability in an oxygen-rich environment. Beyond hardware changes, the tragedy led to a profound cultural shift within NASA. Safety protocols were dramatically strengthened, quality control measures were intensified, and testing procedures became far more rigorous. The lessons learned from Apollo 1, though born from immense loss, ultimately transformed the agency's approach to human spaceflight safety. These systemic improvements were instrumental in ensuring the success of subsequent Apollo missions, including the landing on the Moon, and established a legacy of safety that continues to guide space exploration to this day. The Apollo 1 fire stands as a somber yet pivotal moment in the history of space exploration. It was a searing reminder of the inherent dangers of pushing the boundaries of human endeavor and the devastating consequences of overlooked details and systemic flaws. The loss of Grissom, White, and Chaffee was a profound tragedy, but their sacrifice was not in vain. Their deaths forced NASA to confront its shortcomings, leading to a complete re-engineering of the Apollo spacecraft and a radical transformation of its safety culture. Every subsequent success of the Apollo program, from Earth orbit to the lunar surface, was built upon the painful lessons learned from that fiery January evening. The legacy of Apollo 1 is a testament to resilience, a commitment to learning from failure, and the unwavering pursuit of safety as the bedrock of human exploration. Thanks for watching. If you enjoyed this, please like and subscribe for more engineering history.